Hey guys, welcome to the fourth video. This is Nathan Shankar again. So in this experiment, we're going to be doing the testing and designing of a half wave and a full wave rectifier. So we go ahead and create a file and a new project. Full wave rectifier, full and half. Yep. Okay. So create a blank project. So to start off, we need diodes to create an half wave rectifier. So D1N 4001. So we'll be using this diode uh, in the circuit. So let's place two of them. And LM741, the op amp. Okay. Resistors, two of them. And oops, I think I placed the wrong one. Okay, and we need a sinusoidal source. And two DC sources. Okay, so let's go ahead and wire them up. Actually forgot, we need another resistor. Another one over here. Okay, let's move this a little bit towards this side. Rotate it. Place the grounds. No, not even three. We need four grounds or something. So let's place two of them over here. One here, and another one here. Okay, and let's connect them also. Okay, so basically RF and R1 are supposed to take values of 10K, and this can remain 1K since that's across where you're going to measure the voltage. So let's change these values to 10K. Crap. 10K and this one also 10K. Yep. So that's basically the circuit for an half-wave rectifier. Let's place voltage probe here. Another one. Another one over here. And let's create a new simulation test. Okay. 5 milliseconds. Time domain. Marker is gone again. Okay. Yep. Oh, I forgot one more thing. So we set these values as 0, amplitude is 1, and frequency is 1K, 1 kilohertz. Okay, and AC is 0. The DC values is 15 to 7 and minus 15 to 4. Okay. Yep. So run the simulation. Yeah, so as you guys can see the graph, since we're plotting them both onto the same graph, we're getting it like this. Or you guys can do one thing. Can remove one of the markers, run the simulation. Okay. Come on. Okay, so and you can just where's that? Go to window, no, not a window. Plot, sorry. Go to plot, add plot to window. Go back to the page and add another voltage marker over here. Yep. Getting both of them in green color. Okay. If you want to get it in another color, just add another marker over there. Yeah, and remove this one. So basically, this is the plot that we're getting. So it's the signal is basically at the negative cycle. It's basically halfway rectification takes place. So, moving on to full wave rectification, just some minor changes in this circuit. Okay, so all that we have to do is remove this whole thing and this one too. Okay, place more resistors. Okay. I'm just gonna move this a bit inwards so that it doesn't disrupt the connection. And let's place more diodes D1 and 4001. Well, placing more diodes, we just have them connected like close to each other, not like the previous one where one diode was connected in parallel with the resistor. Now it's not going to be like that. So let's place them together and just gotta rotate them. Nope, not like that. Rotate. Rotate. Gosh. Don't get selected, man. What the hell? Okay. Yep, so we basically connect these two. And this one to this resistor. Yep. And from this It's too short actually. Let's smooth this a little bit more upwards. Say somewhere here. Yeah. And from here we take another wire, connect it in the midpoint. Not exactly the midpoint, just has to be in between these two diodes. Um, um, so we need another resistor. Let's just move this more upwards, closer to it, so it doesn't occupy most of the space. Well, let's place another resistor over here, just parallel to this one, and another one over here. Okay, and let's wire this up over here to this node, and from here we take another one to this diode. Yep. And let's make it 10K again, and 10K. Okay, so you've done one part, the half of the circuit. Just some minor changes have to be done, like you need another op amp, LM741. Let's place it over here. Okay, and it's too close. Okay, so let's take another wire from here, connect it to terminal number 3, not to 2. If in case your op amp is oriented like that, just make sure that you connect it to terminal 3 irrespective of how the op amp looks. And from here you connect it to this resistor. From this resistor you connect it to this node. Yep. Okay. Pardon the net. I mean, what do you say? The light fluctuations. It's pretty bad here. Um, Shit. What am I doing? Crap. Why are you still there? Just move it a little bit more towards the left so you have a clear view of how it is. Then you need another resistor, just for the feedback. Bloody hell. Resistors. Oh yeah. And you take another wire from here to here, and from here to terminal number 6. And you also have to place the DC sources, 2 DC sources. One here and another one here. Let's just connect them before we place the grounds. And this one over here. Just make sure you don't get any exclamatory marks or something like that. So 15 and minus 15. And change these resistor values to 10K. Oh, gosh, not a good day. Yep, 10K, and even this one should be 10K. And yeah, that's it. That's all. Oh yeah, grounds. I forgot about that. Let's place one ground here, another one here. You don't need to connect any ground to this terminal in the other op amp. Third terminal, there's no grounding at all. Okay, done. So the circuit is done. Just have to place the probes and simulate it. Okay, I'm gonna place one here and run it. No, let's run it first so that we'll get a different. We can plot in another graph. So run. Yep. So this is the waveform basically. It's nothing great in that. So we're gonna rectify it. Make sure. Oh shit! Forgot to add another window. Plot. Add plot to window. Now you place your probe. Green color. Hit green. Delete the other one. Okay. So the rectification is there. As you can see, the negative half of the cycle has also been rectified so that you get everything is above, the positive axis. So the signal has been rectified. You can just plot these points if it is required. Uh, Peak points like by clicking it over here and pressing this, hitting the same thing again. So that's pretty much it. And as for the theory, a full wave rectifier circuit looks like this. Model waveform, what we're supposed to expect, and then half waves rectifier circuit is like this, and the negative half has been rectified. So that's all. Um, it's a circuit. So thank you guys for watching. Don't forget to like, share, and subscribe. I mean, it's not really